All right, here we go. All right, first things first, okay? Want to give you guys a few reminders about equations, okay? We are moving into equations again. These are not unfamiliar to you. An equation does have an equal sign, okay? That is the is. An equal sign relates to the word is. We are solving an equation now. We're trying to find out what that variable or what that unknown is. One of the things that I want to remind you about, that equal sign. That equal sign is what divides the equation into left side, right side. Okay? We start talking about balancing equations, you know, this side, that side, guys, that equal sign is what creates those sides. Okay? So you will probably see me draw that line initially on several of these.
I was 3 points off from passing it.
Do I now?
I was 3 points off. And I got a 2. I got the same exact score I got last.
Sorry.
Oh my God.
Okay? Variable term. Variable term. The variable term is the term that contains the variable. Okay? So in this particular equation, that x right there is the variable term, okay? That is the term that we're going to be very interested in because we eventually want to get that variable term by itself, which takes us to the next word, isolate. Guys, your objective is to isolate the variable term and eventually isolate the variable so that the equation is solved, okay? But that's what we are ultimately wanting to accomplish is the isolation of that variable. How are we going to do that? Inverse operations. Guys, with equation solving, you are using inverse operations or opposite operations to undo what you are seeing. If we see addition, we're probably going to have to subtract. If we see multiplication, we're probably going to have to divide, okay? You are going to be using inverse operations to basically undo or unravel these equations to get down to that variable, okay? And then the last thing, guys, remember that 1 is understood. The number 1 can be understood. Right here in front of this x, if you just see a plain old x or a plain old a or a plain old h, there is technically a 1 there. Okay? If you want to pencil those 1s in there, do it. If it helps you to see those, pencil it in there. But I want you to remember that 1 is that one number that is understood. Okay? So just a few reminders there about this equation solving process. All right? Any questions here? Everybody good? There you go. All right. Steps to solve. Okay? Guys, what I'm giving you right here is a general. Let me emphasize general because there's always exceptions. There's all kinds of variations. This is a general structure routine for approaching equation solving. Okay? We always want to look for distribution first. Distribution is oftentimes seen with parentheses. When you see parentheses or grouping symbols, a lot of times there's distribution involved there, okay? Take care of distribution first. Collect like terms on each side, okay? With equation solving, before we start moving stuff around, make sure each side is as simple as possible. So if you have like terms that you can collect on each side and make each side more simple, I would recommend that you do that. Make sure all your variables get to one side of the equation or the other. And we'll see an example of that today. Variables on one side or the other. Typically, you will add or subtract something first. Then you will multiply or divide to solve. Typically. Is that always? No, not always. Guys, this is just a general outline, I think, of how to approach and have some continuity with equation solving. Distribution, collect some like terms, make sure variables are on one side, add or subtract, multiply or divide. There's always exceptions, okay? But try to be consistent in your approach, okay? Any questions here?
I'm not finished yet.
Okay, that's fine.
Oh, wait, yeah, you're fine.
Everybody good? Can I go to the next slide?
Yeah.
Okay, all right. Okay, let's take a look at a few examples. Let's get into the examples. Let's get into the good stuff. All right, top left here. Top left, x plus 2 equals negative 5. I'm going to go ahead and draw a line right there, okay? There's my left side, there's my right side, defined. Guys, what's the variable term in this equation? What's the variable term? X. There's your variable term. Guys, make sure you identify what you're solving for. X is that unknown. We're trying to find out what X is, right? There's our variable term. On the left side of this equation, what else is over there with the X?
2.
A 2. X plus 2, okay? If we are going to isolate or get by itself the X, there's also a 2 over there. What is the inverse of a positive 2? What's the opposite of a positive 2? Guys, we're going to need to subtract 2, right? We need to isolate the X, which means we have to get rid of the positive 2. We're going to do that with subtraction. Exactly. We have to balance, you guys have heard this, you guys have to balance the equation. Whatever you do to the left side, you have to do to the right side. That's why we're subtracting 2 on the right. Guys, your 2's go away. X is isolated. What's negative 5 minus 2? Negative 7. Those darn integer rules, they're not going anywhere. Same sign, keep the sign, add the numbers. X equals negative 7. Okay? Guys, and let me remind you about this, okay? When you solve an equation, okay, we are down to positive 1x equals negative 7. We are solved, okay? How do we know if our answer is right? Okay? If you need to, like I said, if you need to, take the negative 7 and we're going to put it back into the equation for x. Is negative 7 plus 2 equal to negative 5? Yes. Negative 7 works. So just remember that you can do that if you need to. I am not requiring you to plug these back in, but I just want you to be aware you can do that, okay? I had a student yesterday, they called me over during the work and they're like, is this right? And I said, look, I don't mind telling you if you're right, but I said, if this was a test, how would you check that? Plug it back in and see if it works. Okay? All right, top right. Here we go. 3 minus x equals 7. There's my left. There's my right. Guys, what's the variable term? What kind of an x? Okay. The variable term in this equation is negative x. Yes, I know that's a minus sign, but as far as looking at that x and determining is it positive or negative, that minus sign makes that x negative x. That is a negative 1x. What else is on the left side with that negative x? Positive 3. How will you remove a positive 3? Beautiful. we're going to need to get rid of that 3. So if we subtract 3 on the left side, we've got to subtract 3 on the right side. We have to balance the equation. The 3's are gone. Negative x has been isolated. 7 minus 3, 4. Now, is this solved? What's the problem with this? What is still there? Still have a negative hanging around, okay? Guys, we don't have a positive 1x setting there, okay? There is something in front of that x other than a positive 1. You still need to get rid of that. Technically, that is a negative 1 times x. Now, I'm kind of getting ahead here a little bit. What's the opposite of multiplication? Division. We would technically need to divide that by negative 1 now. Negative divided by a negative is a positive. There's my positive 1x that I need. 4 divided by negative 1 is negative 4. So a little bit of an additional step there, okay? All right, bottom left. Bottom left. Guys, these equations right here, these types of equations, when we see them, we need to see these and be able to accomplish these pretty efficiently and with a high rate of accuracy. These are kind of slam dunks, if you will. Okay, these need to be very routine. Okay, negative 4x equals 9. What's going on between negative 4 and x? Are they being added, subtracted, multiplied, divided? They're being multiplied. We should recognize this, right? Negative 4x. How do we undo multiplication? Divide. What are we going to divide both sides by here? Negative 4. Because a negative divided by a negative is a positive. All right, now listen carefully. We're going to divide by negative 4, but negative 4 does not go into 9 evenly. Okay? If you run into a situation like this where the division's not going to work out real super nice, guys, create the fraction. Create the fraction. Leave it as a fraction, but just make sure that the fraction is fully reduced. Negative 9 over 4 is fully reduced. You cannot make that more simple. I cannot divide 9 and 4 by anything other than 1. Can we convert it to a decimal? Sure. Can we convert it to a mixed number? Sure. But I probably would not do that until I was asked to do that. Otherwise, leave it as a fraction, even if it's improper. Fractional answers are okay. They're not favorable, but they're okay. But I have a lot of students that when they get to a problem like this and they see that it's not going to divide nicely, they stop and they go, whoa, wait a minute. What do I do? What do I do? Guys, perform the division step, create the fraction. Just make sure it's fully reduced. This one is, we're good. Okay? All right, bottom right. What's going on between the x and the 4? They're being divided. So if x is being divided by 4, how do you think we're going to get rid of that 4? Multiplication. We're going to do the opposite. We're going to multiply both sides by 4. X is being divided by 4, therefore let's multiply by 4. And what happens here? The 4's gone. There's your x. Isolated the x, it's a positive 1x.
Teachers, please park
Yeah.
interruption.
Gotcha.
Please disregard that bell. Please disregard the bell. Thank you.
Negative 5 times 4 is? Positive or negative? Negative 20. Okay? All right? Questions here on any of these examples? Can I go to the next slide? Okay. All right. Something like this. I'm gonna show you two different ways you can handle this. Okay? And then you decide whatever works best for you. Okay? I am not requiring you to work it one way or the other. Okay? But I'm just gonna give you some options. Okay? You've got 2x over 5 or 2/5 x, however you want to say that. It's the same thing, okay? Equals 3. First method, okay, this is probably the most popular. There's a lot of students right here that recognize that 2x is being divided by 5, so a lot of students want to undo that division with multiplication first, which is fine. We can multiply both sides by 5. That will allow you to cancel those 5s. And what you have left is 2x equals 15 now, because 3 times 5 gives me the 15. Valid approach, get rid of that denominator, use multiplication to do that. 2x equals 15, what will we do now? Divide by 2. And like we just talked about, create the fraction. Create the fraction. It doesn't divide evenly. Leave it fractional. That is fully reduced. We can always make it a decimal. We can always make it a mixed number if we need to. Okay? Everybody okay with that? That is a valid way to do that. Okay? The other method is this. Listen carefully. Any fraction multiplied by its reciprocal, that's taking a fraction, flipping it over, any fraction multiplied by its reciprocal equals positive 1. Any fraction multiplied by its reciprocal equals positive 1. What would be the reciprocal of 2/5? 5 over 2. If we multiply 2 over 5 times 5 over 2, it's 1x. In this case, there's a 1 there. It's 1x. That 2/5 goes away. Any fraction multiplied by its reciprocal goes away, becomes a positive 1. Now, we still need to do that on the other side. Now, notice I put 3 over 1. 3 over 1 times 5 over 2, across the top, across the bottom, 15 over 2. Obviously, we have to get the same answer. Okay? Like I said, it doesn't matter to me which way you do it, but there's a couple options right there for that type of problem. Okay? You can do it in 2 steps or you can do it in 1 step. You decide for you what's best. Okay? All right. Questions here? We okay? Okay. All right. Let's look at some 2-steppers. Let's go to some 2-steppers. Guys, in a lot of this, hopefully you start seeing enough of these again to where you start visually kind of recognizing what you're going to need to do. Okay? What's the variable term in this equation? Well, even more so, 3x. 3x is your variable term here, okay? Guys, you're trying to solve for x. If there is anything in front of that x other than positive 1, you're going to have to do something with that. There's a 3 setting in front of it. It's being multiplied to x. Guys, I bet you're probably going to have to eventually divide with that. Okay? Isolate the 3x first, though. What are you probably going to get rid of first? How? Add 5. That's right. Good. You will generally add or subtract something first, then you will multiply or divide to solve. Add 5 to both sides. Isolate the variable term. 3x is now isolated. 13 and 5 is 18. What would be the solving step? Divide both sides by positive 3, exactly. 18 divided by 3 works out really nice, positive 6. Okay? Isolate that variable term first. Okay? All right, one on the right there. What would we probably need to do first? Say again? Add 3. Here's your variable term, x over negative 2. Isolate it. Let's get rid of the negative 3 first. So let's add 3 to both sides. How do we get rid of the negative 2? Multiplication, that's right. X is being divided by negative 2. Again, we're recognizing that. Let's do the opposite. Let's multiply both sides by negative 2. Negative times a negative is a positive. There's my positive 1x. 11 times negative 2 is negative 22. Again, these types of equations need to be slam dunks. We see them, we're like, okay, can a careless mistake happen? Sure, okay. But these types of equations we need to be able to do efficiently and with a high degree of accuracy, okay? All right, so far so good? All right, let's roll this in here. Obviously, what are we seeing in this one that we haven't seen yet? Parentheses, okay? And as we mentioned before, a lot of times if we see parentheses or some type of grouping symbol, distribution is probably involved, okay? Distribution needs to be taken care of first. Let's make sure that we can distribute this 4 throughout the parentheses. Make sure it gets to both items. What's 4 times x? 4x. 4 times 3, 12. Make sure all the distribution gets done. Get rid of those grouping symbols to start with. Guys, keep your equal signs lined up. Use your equal sign kind of like a decimal. Keep it lined up. Keep things on their respective sides. Try to stay organized the best you can in your work. What's probably going away now? What's the next move? Minus 12. Love it. 20 minus 12 is 8. Solving step. Divide by 4. Excellent. X equals 2. Get the distribution done, turns it into a nice 2-step equation. Boom, 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 very straightforward. Nice, clean answer, we're good. Okay? Questions here, we good? Everybody good? Everybody good?
Yeah.
All right. No parentheses, but what do you notice about this one? What's different about this one? Say again. There's another problem on the other side of the equal sign that contains a variable, right? Good. So right here, you've got variables on both sides of the equation, okay? There is no distribution. 3x minus 2, I can't do anything with that. I can't do anything with 2x plus 8. Those terms are unlike. Guys, if you have variables on both sides of the equation, get them to one side or the other. It does not matter which side you take them to. Totally your preference. Which side do you want the x's on, right or left? You want them on the right or left? Okay, it doesn't matter. If you want the variables on the left-hand side over here, which one needs to move? 2x needs to move. How will you move it? How do I move 2x from the right side to the left side? I will combine them. What operation is going to allow me to take 2x from the right side to the left side? It's a positive 2x. There you go. Good, good. Guys, if you are going to move things from one side of an equation to the other and you are just simply moving them, I want to move this from here to here, you're going to do that with addition and subtraction. 2x minus 2x, gone. On the left side, 3x minus 2x is 1x. I still have a minus 2. I still have an equal sign. I still have a positive 8. Keep things lined up. Now who's leaving? What are we solving for? Solving for x. Here's my x. What else is on the left side with the x? Negative 2. How do I get rid of negative 2? Opposite operation. It doesn't matter which side of the equation the x's or the y's or whatever it is goes on. Your choice. We just have to be able to move them appropriately. Okay? You okay with this? A lot of times students are worried about, well, I don't want to put them on the wrong side. No such thing. You can't put them on the wrong side. It is a total matter of preference. We just need to make sure that we move things appropriately. Okay? All right. Again, no parentheses here, so we don't need to worry about any distribution, okay? Guys, I want you to look on the left side of this equation. Are there any terms on the left side that you can combine because they are like? On the left side, which terms could you combine, or would you be allowed to combine because they are termed like? 5 and... What kind of a 4 is it? Negative 4. That is correct. The 5 and the negative 4, those are what we call constant terms because they don't have a variable with them. But those are deemed alike. Guys, you are allowed to combine those right now. 5 minus 4 is 1. Now, I would recommend that you go ahead and make those more simple so that you have less stuff to move in this equation. The more stuff you move around, the greater chance for careless mistake. So with something like that, I would suggest, hey, 5 minus 4 is 1. Let's make the left side more simple. Is everybody okay with what just happened?
Yeah.
Okay. Now we would look at it and say, okay, what side do you want your variables on? You want to go to the right or the left? It doesn't matter. What do you want to do? You want to go left? If we're going left, which one's moving? And how's it going to move? 5x is going to move. It's a positive 5x, so we are going to subtract it from both sides. 5x's are gone. What is 2x minus 5x? Good. Negative 3x. We still have a plus 1. We still have equals 3. And I think, and putting them always on the left is fine, because I think that's where we're more comfortable, is going left to right with most stuff. Guys, if that's what you want to do, that's fine. Just make sure that we're moving things appropriately. Who's leaving next? How's it moving? Yes, let's subtract 1. Isolate the variable term. We moved all of our x's to the left. There's our variable term, negative 3x. Let's isolate that. Let's subtract 1 from both sides. What's the solving step? Divide by negative 3. Good. Create the fraction. And that is going to be fully reduced. Guys, try to resist the calculator right here, because you're going to plug that into the calculator and it's going to spit out negative 0.6 repeating. And you're going to go, how do I write that down? Do I put all those 6s? Do I round it? What do I do? Don't do that. Leave it fractional for right now. That's an exact answer. If we need to make it a decimal and round it, we can do that if we need to. Leave it exact. Create the fraction. Okay? All right, one more. What do we see in this one? Parentheses. Probably some distribution involved. Guys, remember, distribution involves multiplication. What do you think a lot of students are going to be tempted to do right out the gate here? What do you think the common mistake is going to be that a lot of students might do? What's staring you right in the face right here? 6 minus 2. And guys, that's why I've got this example here. Be careful. You are seeing 6 minus 2. It's going to be real easy to go, ooh, that's 4. But think, hey, we got distribution right here. This is multiplication. We have got to multiply before we subtract. Leave that 6. We are going to distribute a negative 2 right here. Negative 2 times x, negative 2x. Negative 2 times positive 4, negative 8. We see the subtraction, we don't really see a multiplication symbol. Therefore, a lot of times that subtraction gets done first. Be careful of that. If you see distribution, get that distribution done first. What can we combine on the left side? What is like? 6 and negative 8. Good. 6 and negative 8 is what? What's 6 minus 8? Negative 2. Combine like terms. Guys, if you're on the same side of an equation and you have like terms, just combine them as is. I don't have to do any opposite operations and all that junk. We are on the same side of an equation, 6 minus 8, negative 2. Got it. Simplify it. What do we do next? Add 2. Good. 9 plus 2 is 11. And what's the last step? Divide by? Beautiful. Divide by negative 2. X equals negative 11 over 2. Well, that's a crappy 11, isn't it? Oh my gosh. Where'd that go? That just disappeared, didn't it? Here, let me put this back up here. That's kind of weird. X equals negative 11 over 2. There we go. Okay, create the fraction.